In this video, we're going to be looking at the leading term test. So the leading term test says if a sub n times x to the nth power is the leading term of a polynomial function, then the behavior of the graph as x goes to infinity or as x goes to negative infinity can be described in one of the four following ways. So if the degree of the polynomial function is even, and if the leading coefficient a sub n is greater than 0, in other words, if it's positive, then the graph is going to look like this on both ends. So in other words, as x goes to negative infinity, the y value is going to go to positive infinity, and as x goes to positive infinity, the y value is going to go to positive infinity. So I call this an up-up look, okay? Now this is the end behavior. We don't really know from the leading term test what's happening in between, but on either end of the graph, the left end and the right end, the graph is going to be going up under these conditions. Now if the degree of the polynomial function is even, and if the leading coefficient is negative, in other words, if it's less than 0, then the end behavior is going to be down on the left and down on the right, okay? So as x goes to negative infinity, y goes to negative infinity. And as x goes to positive infinity, y goes to negative infinity. Now if the degree of the polynomial function is odd, and if the leading coefficient is positive, then on the left side of the graph, as x goes to negative infinity, the y value is going to go to negative infinity as well. So the left side of the graph will go down forever, and the right side of the graph will go up forever. So as x goes to positive infinity, y will go to positive infinity. But if the degree of the polynomial function is odd, and if the leading coefficient is negative, if it's less than 0, then we'll go up on the left side and down on the right side. So again, as x goes to negative infinity, y will go to positive infinity. And as x goes to positive infinity, y will go to negative infinity. So we have four possibilities for any polynomial function. Again, if the leading coefficient is positive and if the degree is even, then we have an up-up scenario, up on both ends. But if the leading coefficient is negative and the degree is even, then we have a down-down scenario. The graph goes down on both ends. If the degree is odd, though, and the leading coefficient is positive, then we are down on the left and up on the right. And if the leading coefficient is negative and the degree is odd, then we're up on the left and down on the right. And so again, the part in the middle, we just put some squiggle marks there because this test does not help us determine what's happening in the middle. It just helps us determine what's happening on the ends. So let's consider an example. So use the leading term test to describe the end behavior of the graph of each function, okay? Now this particular function in part A is written in decreasing order, okay? So our leading term is negative 0.4 x cubed. So the degree is 3, so we have a degree of 3, and the leading coefficient is negative 0.4. So we have an odd degree and we have a negative leading coefficient. So this is a scenario where the graph is going to be up on the left-hand side and down on the right-hand side. Okay? So again, I don't know what's happening in the middle based on the leading term test, but I know that the end behavior is going to be up on the left and down on the right. Looking at our second function, now this function is not written in decreasing order. So let's begin by writing it in decreasing order. So we have 2x to the fourth. There's the term with the highest exponent. Then next would be minus 6x cubed. Next would be minus x squared plus 7x plus 10. So I've written this in decreasing order so that I can tell that my leading term is 2x to the fourth. So our degree for this polynomial function is 4, and the leading coefficient is 2. So we have an even degree and a positive leading coefficient. So this means that we have an up on the left, up on the right scenario.